All right, so for problem number 9, a 200 kilogram gorilla is sitting in a tree. Okay, so we have to draw a free body diagram for a 200 kilogram gorilla. All right, gorilla. All right. Okay, so we have our 200 kilogram gorilla sitting in a tree. What are the forces acting on the gorilla? So what are the forces acting downwards? By now we should really have that down pat. We have the force due to gravity. And what is the upwards force? Keeping in mind the idea that he is resting on this tree limb right now. So what is the upwards force acting on the gorilla? That is the normal force. We're going to think of this as a surface right here. Okay, and are there any other forces acting on the gorilla? Is there anything moving left or right on the gorilla at all? No, he's just sitting in a tree, right? Okay, and it says a 200 kilogram gorilla. What is that telling us? Well, if it's 200 kilograms, we know that's our mass. Okay, so this is going to be my first time actually bringing this up, but let's do something here. Let's do a little bit something extra. Let's calculate out what our force due to gravity is, what our weight is. So, force due to gravity is equal to mass times the acceleration due to gravity. We said in the previous unit, the unit of freefall, the acceleration due to gravity is equal to negative 9.8 meters per second squared. Okay, I purposely left out the negative over here because what did the negative represent in our freefall problems? Hopefully you're saying to yourself that the negative represented the direction, which was downwards. What we have over here is the idea that the force due to gravity is already acting downwards. I don't want to account for the direction twice, so therefore I'm actually going to leave out the negative in this 9.8 meters per second squared. I don't want to account for direction twice. We're already saying that the force due to gravity acting on the object is acting downwards, so I don't want to account for it twice. Okay, so force due to gravity is mass times acceleration. What's the object's mass? Times acceleration. And what's 200 times 9.8? We have a force of 1960 newtons, and that is the force due to gravity. Okay, and that's this problem.